Hello boys and girls, this is Daniel for Rock the JVM, and in this video I'm going to talk about Akka actors, and in particular I'm going to talk about an interaction pattern known as message adapters. So this video will assume that you're a comfortable Scala programmer and you know some Akka actor fundamentals. If you don't, we have an Akka Essentials course here at Rock the JVM, which will soon be updated with Akka Typed, which discusses everything in detail. Now, I'm also going to brush upon the essential concepts that you are going to need in this video so that this video is self-sufficient for you. That said, I'm going to recommend that you code with me, as always, and whenever you need to refresh your memory about these concepts, just refer back to this video or to the written form at the blog with the link in the description. Alright, so with that being said, let's get back to our code. So I have an object here that I called Akka message adaptation, and I'm going to add a main method because we're going to test something at the end. And I use Akka typed in this video, and in particular, I'm going to go to my build SBT, and we have Akka version 2.6.13 at the moment of this recording. So we're using Akka 2.6, and the library that you will need to add for your project in order for your code to run is com typesave akka %% akka actor typed %akka version. And this particular SBT addition that you will need to add is also in the blog, so you can copy and paste that into your project. Alright, so with that being said, we have a situation here, and I'm going to describe a scenario where you will need a special kind of interaction pattern between actors. And just to make the code a little bit easier to write so that you don't have to type everything with me, open the blog version and copy the first part of the article. So the first chunk of code you can simply copy and paste. So from the object store domain all the way to the end of the first snippet, you can copy and paste into your project. And I'm going to import Akka actor typed actor ref, and you're good to go. So we are going to operate in a fictitious scenario working on an online store, on the back end of an online store. So we have here, and I'm going to explain what the code does. And if you want, you can pause the video and copy the first snippet in the blog version and add it to your project so that you know what we're talking about. And I'm going to explain what each of these pieces mean. So for starters, we are working on an online store where we have a case class called product. And of course, you may have lots and lots of other common data structures for your online store. You may have a user, you may have orders, you may have everything in between, but just for the scenario in this video, we're dealing with products, and products have names and prices, just to make things simple. All right, and we are going to store these data structures in what we call store domain. You might organize this a little bit differently in your production application. You might have a common package and stuff like that. And I'm going to simply keep a object with all of these definitions. All right, then I have an object here that I called shopping cart. And the shopping cart will represent an actor that will receive requests and will issue back responses. And the traits request and responses are being laid out here. And for the sake of this example, I have a single implementation of the request. And the shopping cart actor might have a bunch of possible requests that it might support. And for the particular scenario that we're dealing with in this video, I have a small case class getCurrentCart. This is basically a query for the current shopping cart with the ID cart ID. And this shopping cart might interrogate a database, and it will figure out all the items associated to this shopping basket, the cart ID. So when you initiate a session to your shopping cart application on the web, for example, the web will issue a cart ID which is unique to you, and this shopping cart actor will query a database which already holds the most recent state of your shopping cart with respect to your cart ID. And this getCurrentCart message that the shopping cart actor will receive contains the cart ID, which will be the key at which you're going to query your database, and you're also going to have an actor ref where you're going to send back your responses. So this will be an actor ref typed with the response. All right, cool. And the response trait only has one possible option, which is the one-to-one correlation to getCurrentCart, and the response to that is the current cart. And the current cart message contains the cart ID for which you have a list of products associated to that session. So nothing rocket science here. You have an object shopping cart, which will also contain your shopping cart actor, which will deal with cart IDs and items associated with those cart IDs. All right. Then we have a second actor that we called checkout, and this checkout actor will also receive requests and will issue back responses. And just for the sake of this example, we're going to keep things simple. We're going to have a trait request, which is private to this object checkout, and we have a single query for this checkout, which is inspect summary. So the checkout actor will deal with the total amount due to you by the customer associated to that particular card ID. So the customer will need to be shown how much they will need to pay for what they intend to purchase from your online store. So you will query this checkout actor by your session ID or cart ID, and the response to that is going to be an amount, which is the total price of all the items associated to this cart ID. Now, the flow of queries are going to be the customer actor will interrogate the checkout actor, and this will also interrogate the shopping cart actor. So the customer, in order to find out how much they need to pay to your online store, this customer will interrogate the checkout actor, and to find out how much the customer needs to pay, the checkout actor will need to interrogate the shopping cart actor to find out what kind of items that cart contains, and the shopping cart actor will reply to the checkout, and the checkout will reply to the customer. All right, so this will be a simple back and forth query between these three actors. Now, with respect to the customer, the checkout actor that sits right underneath the customer, that the customer queries directly, this checkout actor is called a front end. So I'm going to do that, and I'm going to call this front end. So the checkout actor is called a front end, and the shopping cart is called a back end. That is because the customer has no clue as to what's happening behind the scenes so that the checkout actor can issue the correct response to the customer. Now, because this front-end actor sits in the middle, what kind of messages does this front-end actor need to support? And the naive solution, or the naive approach to implement this checkout actor, is to have a behavior, and I'm pretty sure you know what a behavior is. This is the description of the kind of messages that this actor can receive. And this checkout actor can have a behavior that will contain something that deals with checkout.request, and I'm using this fictitious 6 and sign so that you can also deal with shopping cart dot response. So in some way, this checkout actor needs to receive requests from the customer and responses from the shopping cart. And this poses a problem. This is an anti-pattern, because if we go along this route, then imagine what would happen in an actor, for example, checkout, which is interacting with many other kinds of actors in your system. Just assume that you are dealing not with shopping carts, but also with order dispatching, with order tracking, with inventories and things along those lines. So the checkout actor might interact with many other actors, and they will need to respond back to the checkout actor, and the checkout actor will need to deal with those responses too. So this is an anti-pattern. So this is bad. And the rule of thumb is that each actor needs to support its own request type, for example, this checkout.request type, and nothing else. So in order to do that, if our checkout actor needs to receive messages, that is replies, from the shopping cart actor, we need to turn those replies into the kind of requests that the checkout actor needs to support. And the easiest way to do that is to wrap those responses into a checkout request instance. So I'm going to add here in the checkout actor, under the trait request, I'm going to add a private final case class. And I'm going to keep this private because the customer actor doesn't need to know about the existence of this class. I'm going to call this wrapped shopping cart response. And this will be a response of type shopping cart dot response. And this extends the request that this checkout actor needs to support. Cool. So whatever responses we receive from the checkout actor, that is this kind of response, then we need to automatically wrap those into this kind of message that the checkout actor needs to support. So this part was easy. The second step is to somehow automatically convert instances of these responses to checkout.request, in our case, this wrapped stuff. And Akka offers a first-class API for doing exactly that. So I'm going to define an apply method that will return a behavior, that is the code that will power an actor instance. So I'm going to have an apply method that will have a shopping cart as a actor ref of shopping cart.request. So this will be the actor instance that will power shopping cart. So the behavior will be of shopping cart.request. So this is why I'm using a parameter here to do some sort of a dependency injection at the very end. And the return type of this apply method is going to be the behavior of this checkout actor, and this is going to be a behavior request. And in order for us to do that, I'm going to say behaviors.setup. And in order to take advantage of IDE completion, I need to import both behaviors from the Scala DSL, the plural, and behavior, singular, from Akka Akka Typed. So behaviors.setup, and this behavior.setup takes a lambda function from context, which is the actor context, and we're going to spawn a child pseudo actor in the form of a message adapter. So I'm going to name this message adapter of type actor ref, of type the kind of message that we don't want to support but we want to wrap, in our case shopping cart.response. So this is the kind of message that we don't want to effectively support, but we want to automatically transform. So I'm going to say actorref of shopping cart.response, and this will be, and I'm going to say context.messageAdapter. And this message adapter method takes a lambda, and the lambda takes an argument of the type shopping cart response that I'm going to receive from the shopping cart actor, and I'm going to wrap that, I'm going to turn that into this wrapped SC response that I defined earlier. So I'm going to say response arrow, and I'm going to wrap it. So I'm going to say wrapped SC response of that RSP. You can also shorthand this lambda, but I wanted to make it explicit. All right, so this message adapter is kind of like a fictitious actor, which upon receiving this shopping cart.response message will wrap that into this wrapped SC response, and it will send that to me, this checkout actor. So this solution is a quick way to ensure that the checkout actor, this thing that I've defined earlier, is only responsible for message of type checkout.request. So these are the only class hierarchy that I'm going to support. Of course, the actual logic of handling the response from the shopping cart actor will have to live somewhere, and I'm going to show you where, but the responsibility is defined in terms of this declared actor type, and now I'm going to type the actor with checkout.request. So at this point, we can implement the rest of the logic of the checkout actor, which is beyond the scope of the adapting technique. So this was the core of the message adapting technique. And let's assume that we're keeping track of multiple users checking out at the same time, because this actor wants to be asynchronous, of course. So I'm going to define a stateless actor. And by the way, we have a video here on the Rock the JVM channel about stateful and stateless actors in Akka Typed. So I'm going to define a method. Let's call this handling checkouts, and I'm going to define this method inside the apply method because I'm going to make this auxiliary. So this handling checkouts method will take, let's call this checkouts in progress, and I'm going to have that as a map of string, which is the cart ID, and the actor ref to which I need to respond back with the state of the checkout, which is the total amount that they need to pay. So I'm going to have actor ref, and I'm going to type that with the generic response. And this method will be a behavior of type request. Now, the way that I'm going to do this is I'm going to say behaviors.receive, And receive, I'm going to use the flavor of receive message because I don't really need the context in this particular behavior. So I'm going to have receive message, and the receive message will simply take a function from the message t to the new behavior that the actor will turn into. And in this case, I'm going to simply use a partial function. So I'm going to lay out a bunch of cases here. So I'm going to have a case for the one request that I really need to support from the customer, which is this inspect summary thing. So I'm going to have inspect summary with the cart ID, and let's call this reply to. Okay, and to that end, I'm going to interrogate the shopping cart actor because this is how the flow is going to work. So if the customer sends to this checkout actor this inspect summary thing, I'm going to interrogate the shopping cart actor with the appropriate request. So I'm going to say shopping cart, because I have the shopping cart here in the factory apply method, so I have access to that. And I'm going to tell that, and I'm going to use shopping cart.getCurrentCart. And I'm going to pass this cart ID and this new message adapter. And that is because if you remember from the shopping cart actor can receive this message get current cart, which contains the cart ID and the actor to reply to with the appropriate response. And thankfully, we now have a message adapter, this pseudo actor that is responsible for handling all the responses from the shopping cart actor. And so I'm going to use this message adapter as my destination. So I'm going to pass this message adapter inside. So this is how we can use this message adapting feature here in Akka Typed to be able to automatically convert the responses back to me, back to the checkout actor. Cool. And I'm going to also change my state, and I'm going to say handling checkouts, and I'm going to add something to the map. So I'm going to have checkouts in progress plus an association between the cart ID and this reply to customer. So I'm actually going to rename this to customer so that we can read the code a little bit better. And now we also need to handle the wrapped SC response that is resulting after this message adapter pseudo actor has done converting the response from the shopping cart. So I'm going to have a case for this wrapped SC response with response. And this is the place where I handle the logic of dealing with the response from the shopping cart. So logic for dealing with response from shopping cart. So this a message adapter technique doesn't shun the responsibility of actually providing any logic for the shopping cart responses handling, but this will take care of the behavior type of being behavior of request. So this operates at the type level. That is because otherwise I would have had to type this behavior with handling all the possible types from checkout.request with all the possible responses that I might need to handle from all the actors that I'm interacting with. So this is very important from the type level perspective, because if this actor is interacting with many other actors, the only possible type that will handle basically everything is a behavior of any, and this will probably destroy the or 99% of the Akka typed rationale. So we want to have typed actors, and so keeping track of types is fundamentally important. And so here is where I'm going to deal with the response from the shopping cart actor, and I'm going to do a pattern match here. So I'm going to say response match. In case I get a current cart with cart ID and items, I'm going to compute a summary here. So I'm going to say val summary as summary. And the summary is the response that I need to send back to my customer, and I'm going to fetch the customer shortly. So I'm going to have a summary with the cart ID that I've just received responses for, and I'm going to compute the total amount that the customer owes me. So I'm going to say items.map, and I'm going to say underscore price. So this will be a list of all the prices of every single item in the shopping cart. And then I'm going to do a sum over those to compute the total amount. All right. Now, I will need to fetch the customer, which is the unique mapping of this cart ID. That is because this handling checkouts method is a stateless behavior consisting of the checkouts in progress, which is a map between the cart ID and the customer that needs to receive my response. And so I'm going to retrieve the customer. So val, I'm going to scroll down a little bit so that you can see the code better. So I'm going to say customer as checkouts in progress applied to cart ID. Now at this point you might want to for example, check whether your cart ID is in the map, but the way that we constructed this code, we're pretty sure that the cart ID is in the map. So if you want to do some additional testing or be a little bit more careful here, you might want to add some additional checks. But I'm pretty sure that the customer exists in the map, and so I will need to say customer tell, and I'm going to pass this summary thing that I've just constructed because the customer is an actor ref of response, and my summary message here extends the response. All right, and then the final behavior that I'm going to return after this whole function is behaviors.same, because I don't really want to change the behavior. Perhaps if you want, you can remove the customer from the map. That is, if you don't want to deal with them. For example, if you're also dealing with some inventory actor or some order dispatching or whatever, and so you might want to keep the checkouts in progress here in your state and maybe deal with other actors, and whenever you finally dispatch your order, you can then remove your customer from the checkouts in progress map, because at that point, your job is done. So at this point, you might or might not want to remove the customer for the map. I choose to return behaviors.same, but you might as well do handling checkouts with checkouts in progress minus cart ID if you really want to remove the customer from your association and make your job complete. Now, the logic of this checkout actor is pretty much complete, but this apply method will need a return value, and the IDE doesn't really show that to me, but I'm going to make this code a little bit more compact so you can see. So now we have the apply method returning behaviors.setup, and at the end we need to return a behavior. And this is where this method becomes useful because we have written it as an auxiliary method. So I'm going to start a handling checkouts with an empty map. All right, so this is the final behavior that we are going to return after behaviors.setup. All right, so we have a checkout actor. Let's also do a dummy implementation of this shopping cart actor, which queries a fictitious database. So I'm going to define a small database as a map, as an in-memory map. So I'm going to define a valid DB as a map from string to list of product. And I'm going to create a map which has the association between a shopping cart, let's say 123-ABC and dash I don't know, 456, or you might want to use a unique identifier if you want. And I'm going to create a list of product, and I'm going to use, let's say, iPhone with $7,000,000 or whatever an iPhone costs these days, and another product. And I'm going to use a selfie stick or whatever, and let's say $35. Okay, so now we have a list with two items associated with a cart ID, and I'm also going to define an apply method that doesn't take any arguments, and this will return a behavior of request. And I'm going to use behaviors.receiveMessage. I don't really need the context here, and I'm going to pass a partial function in case I get a getCurrentCart with a cart ID and reply to. I'm simply going to query my in-memory database, and I'm going to reply back to this actor with whatever I find in the database. I'm going to say reply to tell current cart with the same cart ID and whatever I find in the map. So I'm going to say db apply to cart ID. I don't really care if my application crashes at this point. It's a dummy actor, and I'm going to keep my behavior. I'm going to say behaviors.same. All right, so I have a shopping cart. I might as well call this apply method dummy or something like that. And we need to integrate those in main application. So in main here, I'm going to define a root actor system, and I will need to define that actor system in terms of its guardian behavior. So I'm going to define a root behavior as a behavior of any. So I'm going to have behavior.of any because I'm not going to receive any messages here. I might as well type that to behavior any, and I'm going to use behaviors.setup, and given a context, I'm going to spawn 3 children actors. So I'm going to spawn a customer, I'm going to spawn a checkout, and I'm going to spawn a shopping cart. And I'm going to start with a shopping cart. So I'm going to say val shopping cart as context.spawn. I'm going to say shopping cart.dummy. So this will be the dummy behavior, and I'm going to name this shopping cart. Cool. Then I'm going to spawn a customer, and I'm going to have to create the behavior on the spot. So I'm going to have, let's call this customer as context.spawn, and I'm going to use behaviors.receive message. And again, I'm going to use a partial function here. So in case I get a summary, which I'm going to receive from the checkout actor, and by the way, I will need to import the checkout domain. So I'm import checkout everything, and I'm going to go to the top of my file because I don't want to import that at the top. So I'm going to receive a summary message from the checkout actor, and in case I get a summary with the card ID that I don't care about and the total amount, this summary will print to the console. So I'm going to print line or show things on the web page. For example, total to pay, and I'm going to use the amount, pay by card below. Okay, or something like that. And I'm going to keep behaviors.same because I'm not going to receive any other messages. And the name of this customer is going to be customer at the very end. So the name of the actor is the final argument of context.spawn. So we have a shopping cart, we have a customer, we need a checkout. So I'm going to have val checkout as context.spawn, and I'm going to have checkout applied to shopping cart. So this is where I do this dependency injection kind of pattern. So this shopping cart will be the actor that I'm going to use for the so-called backend, and the name of this actor is going to be checkout. Cool. And at this point, at the very start of this root behavior, I'm going to start the interaction. So I'm going to have checkout tell inspect summary with the cart 123-abc-456, and the actor that this is going to reply to, this is going to be the customer. Okay. Now, the customer is not typed with anything because behaviors.receive message and passing it a partial function is not helping the compiler, so I need to type that with checkout.response. And now the customer is properly typed, and the behavior of this root actor is not really important, but it's important to the compiler, so I'm going to have behaviors.empty. So this root actor will not receive or handle any messages. All right. Now, after I've defined this root behavior, I need to set up an actor system. So let me scroll down a bit, and I'm going to have a system as an actor system. And I'm going to use this root behavior, and the system is going to be the main app or whatever. And after a second, after the system has been spawned, this whole interaction already has taken place, I'm pretty sure of that. So after a second, I want to tear it down. So I'm going to have system scheduler schedule once, and I'm going to use one.second, and the second method is not available unless I import the appropriate duration. So I'm going to import Scala concurrent duration everything. So this is what enables this one.second construction over here. And the function that I'm going to trigger after 1 second is a noarg function, and I'm going to say system.terminate. Now, this schedule once thing will need an execution context that it needs to run upon. So I'm going to use the actor system's default dispatcher, which also acts as its execution context. So I'm going to define implicit val ec, let's call this of type execution context from Scala concurrent, and I need to fetch the default dispatcher of this actor system. So I'm going to say system dispatchers lookup, and I'm going to use dispatcher selector dot default. So this is the default query that is going to return a dispatcher, which is a thread pool on top of which futures can run, upon which message sending can occur, and so on and so forth. So this will be the execution context that will also run this function after 1 second when the actor system needs to tear down. And at this point, our code is complete. We wrote 100 lines of code in this small video. And so we need to trigger this interaction pattern, and this will trigger once the actor system is being spawned. So all we need to do is run this application. So right click and run, and hopefully my code compiles and runs correctly. Let's see. It takes a couple of seconds for the compiler to run. It also compiles all the other sources of this YouTube channel, I think. Let's speed this up a bit. All right, so this compiled, and we have the interaction here in the logs. So total to pay 8923618.0, which is the price of the iPhone, 8923583 plus 35, and 583 plus 35 is 618. So the total has been computed correctly. And so our entire flow worked from beginning to end. Now, the code over here is, or has become, quite verbose, but this is what you expect when working with actors, and I really wanted to have an end-to-end example, not just the technique of message adapters and dealing with the appropriate logic in the proper place. Alright, so I hope you found this video useful and enjoyable. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Leave me feedback in the comments, I read every single one, and check me out on Twitter and LinkedIn. I post fresh updates on upcoming material. I've just released the Scala and Functional Programming Practice update with more Google-style interview problems, so you can check them out at rockthejvm.com. I post all the content and all the courses related to Scala and Akka and Functional Programming and Apache Spark and Zio and Cats and all that kind of stuff at rockthejvm.com. I'm Daniel, signing off.